Here we have a very simple and interesting question, but students often make a very common mistake and then run around in circles trying to prove this result. But then we will cross the bridge when we come to it. We don't have to worry about mistakes now. First, let us see what this question is all about. What we are going to prove here is a general result, which means it works for any triangle under the sun. Now, as usual, we have denoted the three vertices using capital alphabets and the measure of the sides, all the sides, using small alphabets corresponding to the opposite vertex. Now, not only that, we have three medians. What are medians? They are line segments which join a vertex to the midpoint of the opposite side, which means here you have an A by 2 and here you have an A by 2. Not only that, what does the median do? It splits the triangle into two equal areas, or in other words, two triangles having same area. Now consider any one of these triangles. I will just take this one. Let MA be the measure of the median from A to the side BC. Then the measure of the three sides of the triangle looks like this. Now what does the triangle inequality rule say? The sum of any two sides is greater than the third side. Now here you have to be very careful because the inequality works in three different ways. Now, all of these three inequalities are correct if you take any two sides of a triangle, the sum of any two sides of a triangle, it is greater than the third side. But then this equation is the one which is going to give us the correct answer. Now, these two are perfectly legal, but if you go down this road, you will just get an answer which will be mathematically correct, but it will not help you arrive at the answer. So please notice that what we are dealing with is an equation which gives a quantity which is greater than one of the sides of the triangle. That is what we are looking for. Now let us get rid of this median here and construct the next median. Now let us construct the median from the vertex C. I have denoted it by MC, and what does this median do? It again cuts the triangle into two equal areas, into two equal smaller triangles. Go for any one. I have taken this one, and then what do you get? The sum of any two sides is greater than the third side. Again, write your equation in such a way that you get an upper limit for one of the sides of the triangle. Now for the last and the final median. Here I have constructed the median from the vertex B. I have called it MB. It cuts the triangle into two equal parts, but this time go for this triangle here. Why is that? If you go for this triangle, you will end up with an inequality which deals with C. But then we already have one such inequality. We don't want to be overloading C. So what we will do is we will go for this triangle, and what do we get? A is less than the sum of these two sides. Now what do we do? Just add all the three of these equations. Then what do you get in the LHS? What you get is the whole of the perimeter. Let me denote it by P. And what do you have here? You have the sum of all the three medians, and we have denoted it by M. And here you have what? So we have proved that our perimeter is less than 2 times the sum of the medians. That is the result that we wanted to prove. That we have arrived at our result, let us go back in time and see why we have to use only this inequality. This inequality which gives an upper limit for one of the sides of the triangle. What is wrong if we go for the other two inequalities? Now suppose I write an inequality which gives an upper limit for one of the medians. Then I will have three such inequalities, right? There are three medians, and I will get three such inequalities. I can add up all of this, and in the end I will get such a result. Is it correct? Yes, it is. but it is not the one we want. Why is this correct? Your sum of the medians will be less than the perimeter. If you want the proof for that, I will give the link in the description box. Your sum of the medians will always be less than the perimeter. Now, if one number is less than the other, it is obviously going to be less than 1.5 of that. That is just more. There is nothing new. It is just a mathematical proof, right? So your median is going to be less than 1.5 of p. So it is correct, but that is not the result you want. Now, what happens if you go for an inequality which gives an upper limit for a by 2? You will get 3 such corresponding inequalities, right? Here I have taken MA. If you take the other two medians in 3 different steps, you will get 3 different inequalities, add all of them, and finally you arrive at such a result. Is it correct? Yes, it is. Why? Because both P and M are the measure of line segments. So they have to be positive. Then minus P would be negative. Any negative number is going to be less than a positive number. Is the answer correct? Is this result correct? Yes, it is. But it is not going to help us. So I often see children thinking that all the inequalities are true, so it will work whatever way we do it. But it does not. Please take care when you write your exams. There are many equations, many formula, but choose the one which takes you straight to your answer. That is all for today. You take care. Assalamu alaikum.